Learning Objective 2 in Section 4.3 is to construct and interpret a confidence interval for the difference of two means. The National Assessment of Educational Progress tested a simple random sample of 1,013-year-old students in both 2004 and 2008, two separate simple random samples. The average and standard deviation in 2004 were 257 and 39 respectively. In 2008, the average and standard deviation were 260 and 38 respectively. Check the conditions, calculate and interpret a 90% confidence interval for the change in average scores from 2004 to 2008. So there are actually four conditions that we need to check. Let me list those and talk about how those are met. The first condition is random. We need to have either a random sample or a randomized experiment. Here we have random sampling, a random sample of both 1,013-year-olds in 2004 and a random sample of 1,013-year-olds in 2008. We need independence. The sample size needs to be less than 5% of the population size. We can be confident that 1,000 is less than 5% of all 13-year-old students in both 2004 and in 2008. Third, we need a normal population for each group or large sample sizes. Our sample sizes are 1,000 in each group. Those are both above 30, and so our sample size is large enough, even though we're not told the shape of the distribution. And fourth, since we're dealing with two different groups, we need those two samples to be independent of each other. The students in 2004 and 2008 were different and unrelated. So these are independent samples as well as independent individuals within each sample. All right, next we're going to calculate the confidence interval. In the GeoGebra probability calculator, we are going to select the t-estimate for the difference of means. Our confidence level is 0.9. They told us to use to compute a 90% confidence interval. And we're going to enter in the mean and the standard deviation from each group. In 2004, we have 257 as the mean and 39 as the standard deviation with 1,000 individuals. We'll use 2008 as our second sample. It had a mean of 260, a standard deviation of 38, and also a sample size of 1,000. And if I scroll this up, we can see the confidence interval. The lower limit is negative 5.8336, and the upper limit is negative 0.1664. So that's our confidence interval. Let me add that in here. There's our confidence interval. We are computing a confidence interval for the difference between means. It's group 1 minus group 2. So it's 2004 minus 2008. That's how we entered in our two different data sets. Our entire confidence interval here is negative. So that means when we subtracted the value from 2004 minus the value from 2008, we got negative values, meaning that the 2004 values are smaller than the 2008 values. The way that we would interpret this is we would talk about the difference in means for the two different groups. As usual, we would talk about our level of confidence that the interval captures the parameter. So it would be something like this. This was a 90% confidence interval, so let me change that. We are 90% confident that the interval from negative 5.8336 to negative 0.1664, let me make sure that those are on the same line so that's not confusing to anyone, captures the difference between the mean score on the National Assessment of Educational Progress in 2004 and in 2008 for all 13-year-olds. So notice we're talking about the population of all 13-year-olds. The students in 2004 likely scored between 0.1664 and 5.8336 points lower than the students in 2008 on average. Since our confidence interval contained negative values, we can say that the likely values for the 2004 minus the 2008 means is negative, meaning that 2004 was lower than 2008. This next example says a random sample of 101 light bulbs of brand A had a mean life of 543 hours and a standard deviation of 23 hours. A random sample of 120 light bulbs of brand B had a mean life of 520 hours and a standard deviation of 29 hours. Construct a 99% confidence interval for the difference in mean life for all light bulbs between brand A and brand B. All right, so we're going to enter in the information that we have. Our confidence level now is 99%, so 0.99. Our first group, brand A, had 543 as its mean, 23 as its standard deviation, and 101 as its sample size. Our second group, brand B, had a mean of 520 with a standard deviation of 29 and a sample size of 120. And we can see that the confidence interval goes from 13.9066 to 32.0933. Rounding, we can see that the correct interval here is answer D.